Hello everyone. This is a walkthrough of the Racket programming language. So for those who aren't familiar with what Racket is, Racket is a functional programming language that stems from the Lisp and Scheme programming languages. Uh, it is a good programming language to use if you're learning concepts like recursion, higher order functions, and even immutability due to its minimalist syntax. And for this walkthrough, I'm going to be using the Dr. Racket IDE, which is the IDE that is specific to the Racket programming language. But Racket can also be run on any text editor of your choice or on the command line, so in your terminal. So how you install Dr. Racket is you go to the Racket website, click on download, select the platform that you're working on. In this case, I'm working on a Mac. You download it, and if you're on a Mac like me, you take the downloaded files, put them in your applications, and you'll have access to Docker Racket as shown here. Yeah, I have an instance of Dr. Racket of open here. If you're interested in learning more about the Racket programming language, I found this one resource on the University of Waterloo website, which contains things like training yourself about the basics and pure and impure functional programming with Racket. So yeah, let's get to it. Yeah, and once you open the Dr. Racket IDE, you'll see something called LangRack. This is just a collective package for all the methods in the Racket programming language. Yeah, so once you open up the IDE, you go to choose language, and at first it says teaching language, but then instead click up here to the Racket language, and then you click OK, and then the LangRacket appears. So let's do a bit of a brief uh starter function. So this would be your first function ever in Racket. One and it would be hello world. So one way we can print uh our function to the console down here is doing print and then hello world. And then we press the run button. And yeah, right here in the console, it shows up as hello world. We can also use we use the new line function to skip a line, and then we do display hello world, and it runs that. Except, yeah, this is if you want to print something without the quotations. You can also do display ln or display line. And yeah, likewise, you also have Hello World printed out here. And the nice part about Racket is that when it comes to supporting data types, Racket can support integers, floating point values, rational numbers, as well as Boolean values and strings. Uh, and I guess we could get started on arithmetic operations. And when it comes to arithmetic operations in Dr. Racket, we use prefix notation. So we could do plus 3 and 4. That outputs 7. For subtraction, we could use 6 and 3. That outputs 3. Yeah, and the same method works for multiplication and division. And if you want to find the exponent of something, we use the expt keyword. Let's do 2 to the third power. That outputs 8. And we can also call post prefix functions within a prefix function as well. So we could do multiply, and then we have the result of 6 minus 4, which is 2, and then we multiply that by 3, and we get 6. So yeah, it's this is just a brief intro to how arithmetic works in Racket. The same process goes for finding Boolean values in Racket. So for example, we have is 5 greater than 3? That is true. The same logic goes for checking if 5 is less than 3, and that outputs false. Uh, and yeah, it also not only does it support less than and greater than, it also supports uh greater than or equal to. That also outputs true, as well as less than or equal to, which outputs false. And to check if two elements are equal to each other, we just use a singular equal sign, which outputs false. Or we could use the EQ command equals or, or equal, and that outputs false. It also supports and or, so we could just do if 5 is greater than 3 and 4 is less than 9, it should output true right here. Otherwise, if we put uh, less than and then we switch it to greater than, it should output false, as shown here in the console. It also supports or as well. So we could do if 6 is greater than 2 and 9 is and 3 is less than 9, then it should output true. Yeah, actually, let's just do this. Less than this would still output true because at least one of the conditions has to be true for or. And for string operations, uh, we can perform operations on strings with built-in functions provided in Racket. So we could do string append, which as it sounds, appends to strings. So we could do hello world, run that, and it outputs hello world. We can also find the length of a string using string length. So we could just do world, and it outputs 6. We can also get the substring of a string. So we could just do bracket, and we get it from index 1 uh, up until index 3. So this one is just it just gets the string from index 1 to index 3. So we get ACK. So 1, 2, 3. Like Python, if you're getting a substring, this index 4, uh, it is not inclusive. And we can also convert a string to a list using the string arrow list command. And let's just say we input apple. We get this as our list. And when it comes to displaying characters in Racket, we use hashtag backslash and then the specific character. And this the same also works vice versa. We could do list to string, and we input the same list that we've made from previously, and it outputs apple. And yeah, moving forward, when it comes to assignment of say numerical values, booleans, or strings to a variable, Racket supports that. But how variable assignment works is different from other object-oriented programming languages where you've simply used the variable, the equal sign, and then whatever value you're assigning to it. In this case, we use the define keyword. So let's do x as our variable and 5 as the number we are assigning to it. So basically we're saying here x is equal to 5. Uh, and this is for integers. So we could do it for a floating point value. We could just do 3.14. Same logic here. We're assigning the variable y to 3.14. We can even assign Boolean values to our variables. So yeah, we're setting the true Boolean value to Z. We can also do uh, we can also set strings equal to variables. So the hello variable will contain the hello string. And and variables can also contain lists. So to create a list, we add an apostrophe and then a set of parentheses. And this parentheses will contain the elements 1, 2, and 3. And now let's go into some of the control and data structures that are supported by the Racket programming language. So I guess we could start by showing how if statements work. So here we have an if conditional. Yeah, it just works like your regular if statement, like you do if else statement, like you do in other programming languages. So I just say if 8 is greater than 2, which would obviously be true. Uh, we would say yes if that condition is true. Otherwise, we would say no. And if we run that, it outputs yes. If we change the greater than to less than, it would output no. We can also use the cond keyword. It functions similar to an if-else statement, except that is if you have like multiple conditional statements that you want your function to go through. So how we do that is we have parentheses cond, then we have square brackets, uh, and let's see, if 2 is less than 1, then you output no. Uh, let's do another conditional statement. If 2 is equal to 2, let's output yes. And finally, you add your else. So square brackets else, and then we have our default case. So it's kind of like a yeah, so it's basically a big if else if else block if you used Python. And if we run that, yeah, here we see that since this statement is true, it outputs yes. We can also use for loops in Racket. So we do parentheses for another set of parentheses, brackets, I, and we do in range 5. So if you use Python, in range is similar to the range function in Python. Then we could do display, ln, and I. And it should print indices 0 through 4. And here, if we look in the console, it does just that. And let's close that. And how do we define functions in Racket? So it's kind of similar to how we define variables. Uh, we use the define keyword, and we create our function name and whatever input parameters we want to add. for this function. So let's do a basic function like factorial, or not factorial. Let's just do square with an input parameter n. And it outputs n times n. And let's call a the square function with an input parameter of 2. And it outputs 4. Or let's just say if we try to do one, say a negative value, it outputs 1. So yeah, this is just a basic idea of how functions work. We can also use functions to uh, use recursion. And yeah, this one we're going to be using the factorial example. We create the factorial function with an input parameter n, and we do the we use a con keyword. You can also use the if you can also use the if keyword if that also works for you. So we use cond if 1 is equal to n, then you would output 1. Otherwise, we would use the else keyword, and we do n times factorial of n minus 1. And yeah, this is our recursive function with our base case and our recursive case. So let's do factorial 120. And yeah, it just outputs this huge value. Actually, we'll just do a simple number like 5. And yeah, it outputs 120. We can also use uh functions to create to define specifically local variables and functions. So yeah. So here we can create a function called define. Let's just do one called sphere surface area. And we have the radius as our input. Here we use the local keyword to define any specific variables or functions that are going to be used within our sphere SA function. So let's just do here 2 sets of parentheses, and we call let's see, define pi. And pi, the value is 3.1459. And then afterwards, we're still within the local scope. So yeah, we exit. Yeah, so once we're done defining pi, we go down and we do 4 times pi. Yeah, the area of a sphere of the surface area is 4 times pi times r squared. So r. And yeah, we are done with our sphere SA function and using local to define a variable. We call sphere SA, let's input 2. And yeah, we have 50.26544 as our answer. We can also, yeah, so here's an example where we can define a function within a function. So the local function would be basically a helper function. So define, and yeah, we're going to be using our factorial example, except we're going to be using local. So here we're going to be calling local, 2 sets of parentheses, and we do define, let's call this function factorial helper, where we input n and a parameter n and an accumulator. And yeah, for this one, let's just do an if else using the if keyword. So if n is equal to 0, then just output the accumulator. Otherwise, we just call factorial helper, subtract n from 1, and our accumulator will be updated to be accumulator times n. Uh, and yeah, once we're done defining factorial helper, we call factorial helper n1. So n would be whatever we defined up here, and 1 would just be our accumulator value. And we do factorial 5 should output 120. Yeah, so this is how the local variable can be used to define both variables and functions within a function. And lastly, here are some of the uh, control and data structures that are supported within the Racket programming language. So one would be lists. Here we uh, to create a list, we can use the list function. So I just do something like uh 4 and 3 as our first element and create 9 as our second element. We can also do 8 times 2. And yeah, we get a list with elements 794. We can also use commands to get elements from a list. So we could just say, what's the first element of the list 1, 2, 5? It should output uh 1, as it's shown down here. The same logic can be used to get the second element of a list, is 2, or the third element of a list, which is 3. We can also append one list to another list. So just say we have a list containing elements 1 and 2, and a second parameter containing elements 3, 4, and 5. Append them together, we get 1, 2, 3, 4, 5. We can also calculate the length of a list, 5. That should output 5. We can also use the take and drop methods. The take method, it just takes any number of elements you specify. So if we have a list containing 1, 2, 3, 4, 5, let's say we want to take the first 3 elements of this list. We would get 1, 2, 3. Uh, and if we want to drop certain elements, uh, if we want to drop any number of elements in a list, so we would use 1, 2, 3, 4, 5. Let's drop the first 4 elements in this list. That means we are left with just 5 in our list. Other built-in functions include uh, the reverse function. We could get 1, 2, 3, 5, and it should output 5, 4, 3, 2, 1. So yeah, Yeah. Another data structure that we can use are vectors to uh, create a vector. Let's just define our first vector. So let's just call it this one, v1 vector 1, 2, 3. So yeah, to explicitly call to define a vector, you call the vector keyword. And yeah, to get a specific element at a particular index. So let's just say we want to get a uh the first element of our v1 vector. So we just enter 0 and we have 1. Should be obvious. Another one would be setting a new value into our vector. So we would use the vector set command. So v1 at index 1, we can set the value for 36. So that means instead of our vector containing the values 1, 2, and 3, we would have 1, 36, and 3. We can also calculate the length of a vector. So vector length and our vector should be 3. We can also, to create, another way we can create a vector is we use define v2 and we call make vector. And then we can just say 5 and 0. And what this means is that this creates a vector of 5 zeros. So it's just a vector of size 5 with zeros as its elements. The nice part about a vector is you can iterate over it. So yeah, we can use a for loop. Yeah, I in range. And then we can just call vector length v1. Then we can do display ln vector ref v1 at I, run over each index. And yeah, likewise, here in the console, we see 1, 36, and 3 be printed out. And some other built-in functions we can use with a vector. Like the list, we can convert a, or actually, sorry, the string. We can convert a string to a list. Likewise, we can convert a vector to a list. So to create a vector, it's just hashtag and parentheses. In a list, is just apostrophe and parentheses. 3. Yeah, here is our list. The same works vice versa. We can convert a list to a vector. So 1, 2, and 3. And yeah, this is our vector. Uh, let's see what else. Yeah, we can also append any value we want to a vector. So let's just call it just 4. Let's input a vector 4 to vector 1, and we get this as our new vector. And to create an immutable vector, you could just explicitly call it vector immutable with elements 1, 2, and 3. And yeah, this is our immutable vector. And our third data set we're going to look at are hash tables, or hash sets, whichever we want to call them. And how we do hash sets is let's define a hash set or hash table called HT and do make hash. Make hash makes creates a empty instance of a hash table and sets it to HT. Yeah. And to add a key value pair in a hash table, we do hash set. Uh, and when you define a key, make sure you do apostrophe and the name of your key. And let's set the value to 20. Hmm. Oh, my apologies. Yeah, make sure to add the hash table as your input parameter. And yeah, that means in the hash table, we have our key A and our value 20 inputted. So to get that, to get a value based off of an inputted key, we just do hash ref HD and then A should output 20. Likewise, if you want to remove a key value pair in a hash table, we just do hash remove. And yeah, that is removed. And just to double check if key A is there, we do the command hash as key, ht, and A, apostrophe A. And right here, we see it outputs false. So yeah, it does not have the A key. And another way, we can also make immutable hash tables. So we can have one and B two. This creates a immutable hash table called H2 key with key A with value 1 and key B with value 2. You can't add or remove values from such a hash set. We can also convert a list to a hash table. So let's do H23 make hash and then our list. So here we would have x dot 10 and y dot 20. Yeah, so we have our key value pair of x and 10 and our y value pair of our second key value pair of y and 20. And yeah, if we run that, yeah, no errors there. So we have a hash set of two key value pairs. And this one is not immutable. You can choose to remove or add key value pairs to HD3. Uh, likewise, uh, like we've seen in lists and vectors, you can iterate over hash tables. So we can print the keys, we can also print the values, or we can also print the key value pairs. So let's do for, right? Okay, yeah. Brackets and parentheses. Let's do key, and we do in hash keys of HT2. Then enter. Then we do display ln. Then we print key. And as we see in the terminal, B and A are printed. And yeah, the order in which you insert it, it's kind of like a stack. So in this case, A is put in first and B is put in second. So that means B will be printed first in a for loop, and A will follow second. The same goes for values in a hash table. Yeah, so this would be keys. And to print the values, we would do, instead of in hash keys, we will have in hash values. And let's just do V instead. And right here we see it's 2 and 1. B is equal to two, assigned to 2, A is assigned to 1. And how about printing key value pairs? So square brackets and parentheses within them. Let's have K and V and then in hash of HD2. Then we just do print F, print F, and then we just do tilde A, arrow, tilde A, and yeah, this refers to a data type. If you've used C in the past, this is similar to that. And after that, we just do K and V. We run that. Yeah. We see here that we have B pointing to 2 and A pointing to 1. And as we've seen with our previous list and vector data structures, we can convert a hash to a list. So HD2, and yeah, it outputs this as our answer. And if you want to do it vice versa, then you just uh do the same process like we did here for HD3. And another way that, oh yeah, and one thing I forgot, another way we can use to implement lists is known as compound data. And for that, we use the cons keyword. Let's do 6 and 3. And then we get this as a list. Yeah, this is similar to how we convert a list to a hash set and how this would be an input parameter to of a list to turn it into a hash set, where 6 would be, say, a key value and 3 would be a value. Yeah, but to actually form a list, we can uh do we use the empty keyword. So empty, yeah, it just outputs an empty list. Yeah, but if we want to make add elements to a list, we just do cons 5 and we'll just call this one 8 and hit empty. This creates a list with a single element A. If we want to have multiple elements within a using cons, we would have 8 and then cons. Let's just default true and empty. And it would look something like this, with 8 as our first element and true as our second element. Yeah, so kind of looking at the structure of this, it is similar to a linked list. Yeah, let's add even more elements. So cons, let's do racket, first element, cons, 3.5, a floating point value, cons, 12, and cons, true. empty. And we get this as our list with four elements. And like a list, we can use the first and rest keywords for it. So if we were to get first, yeah, we would get bracket as our first element. Uh, and we can use the rest keyword, which gives us the remainder of the list that we just created. And finally, what else have I missed? Yeah. So that is all. Yeah, so that's it for just explaining uh how some of the basic data structures and uh how to use variable assignment in Racket. Now we move on to functions. Uh and to create a function, we use the define keyword. So let's just create a basic function called square with an input parameter n. And what is the square of an input parameter n? It would be n times n. So yeah, this is how you make a simple function. And if you were to call this function, so square of 4, we would get 16. And here in the console, we see we have 16 as our answer. We can also use functions uh, both recursively as well as tail recursively as well. So we can use define, and a let's see, a basic function, a recursive function would be factorial, and we have n as our input parameter. And how we can do a conditional statement is we could do if, actually, yeah, if, uh, yeah, if n is equal to, actually, yeah, let's just do if n is less than or equal to 1, then you would output 1. Otherwise, you would just do uh n and then call factorial of n minus 1. And let's just call factorial 5. And that outputs 120. Yeah. And another way we can choose to implement a conditional statement would be using uh the cond keyword. Let's just call this one factorial 2 with an input parameter n. We just create another set of parentheses, and then we call the cond keyword. Uh, Cond, it's similar to a if-else statement right here, except if you have multiple if statements you want to go through and end with a default call, then cond would be the best solution for you. So for our first case, we're just going to use square brackets, and then in parentheses, we do if n is less than or equal to 1, then we would output 1. Else, we could just copy all of this. We can just copy all of this. Uh, and yeah, this is just another way we can implement a conditional statement, except we use the cond keyword. And if we were to call factorial 2. My bad, forgot to change that. And then we just do that again. And yeah, we end up with 120. So these are two different implementations of the same factorial function. As for tail recursion, let's do another function example. So for example, if we have a function called uh multiply list, so you're multiplying all the elements of a list and returning a single value. So let's just have a list parameter and an accumulator parameter. We use the cond keyword and we check, is the list empty? And yes, Racket does provide an empty list function to check if a list is empty. And if it is empty, then we just output the accumulator. Else, we just call uh mul otherwise we just call mul list again. This time, our new input parameter would be the rest of the list, while our accumulator for this for our recursive call mul list would be the accumulator times the first of list. And yeah, actually we'll just call this one mul list tail and call this one tail. And then we can define another function called mul list, and we have a list parameter, and our definition for that will be mul list tail, with list as our input parameter and one as our accumulator value. So if we were to do mul list and do 1, 2, 3, 4, and call that, and we would get 24 as our answer. Otherwise, we could just call the tail recursive function directly and have our accumulator value as 1, and we will get 24 again. And next, we are going to be going into higher order functions. And higher order functions are the built-in functions map, filter, and fold. So the fold functions are fold L and fold R here. And within these higher order functions, we're going to be using lambda functions. So if you're not aware of what lambda functions are, they are just functions that are defined anonymously with no name. And they're just typically called within a function operation. And I'll show that right here. So for our map function, we are going to be let's say we triple or cube all the numbers of elements in a list. So we do lambda x and then we do x x x. So we're cubing each element of a list. And then we do 1, 2, 3, 4, 5. So our list input parameter. And we get this as our answer. Now let's go on to filter. Say we want our lambda function to remove all the even numbers and keep only the odd numbers. So we have lambda x. And the nice part about Racket is that it provides an odd inbuilt function. It also provides an even inbuilt function to check if x is either odd or even, depending on function you call. And we have 1, 2, 3, 4, 5, and voila, we have 1, 3, and 5 as our result as all even numbers are removed. And let's use fold L for our third higher order function. Here, let's try to find the sum of all elements in a list. Or actually not sum, let's just find let's multiply all the elements of a list and return a single answer. So let's do lambda, and here we have an accumulator and x as our input parameter. And here, the accumulator value will be uh, the accumulator value times x. So lambda function done. We have 1 as our accumulator value, and then our list parameter would be 1, 2, 3, 4, 5. And it outputs 120. So this is kind of like a bit of like a factorial function, multiplying from 1 to 5. Or if you want to simplify this, you could just get rid of the lambda function altogether. Just replace it with the multiplication operator. And if we run it, it still outputs 120. Now for fold R, let's define a lambda function, x, with parameters x and accumulator. Oh yeah, and then for this fold R function, we are going to be subtracting elements from left to right in a list. So here we would have the new accumulator value will be updated to the value of x minus the accumulator. And our accumulator value would be starting at 0. And our list parameter would be 1, 2, 3, 4, 5. And it will output 3. And lastly, for functions, we are going to be, let's talk about local variables and functions within a function. Yeah, so these would essentially be local variables will be variables called within the scope of a function, while local functions would just basically act as helper functions for the function you declare inside. So an example of a local variable would be the the surface area of a sphere so let's define a function called sphere SA with an input parameter of r, and we use the local keyword to define our local variable or local function. So here we would just have two sets of parentheses, define pi 3.1459. And once we're done defining that, we then enter. And yeah, keep in mind we are still within the local scope. We are not outside of it. So once we're done with defining our variable, we come down, and the surface area of a sphere is 4 times pi times r squared. So we just do 4 times pi times r squared. And yeah, we are done with our sphere as a function. And we call the sphere as a function with an input parameter of 2. Then we get an output of 50.26544. And now let's do an example where we use uh, the local keyword to define a local function. So define, and we're going to go back to our factorial example. So factorial of n, local here, we define a function called factorial helper with n and the accumulator as our two input parameters. Here we call the if statement. If n is equal to 0, then return the accumulator. Otherwise, call the factorial helper with n being decremented by 1 and the accumulator being multiplied by n. And yeah, once we're done defining this function, uh, we then call factorial helper, then n from our input parameter, and 1. And that is our factorial function called with a helper function using the local variable. And if we call factorial of 120, or not 125, then we would have 120 as the result. And our last concept that I want to, uh, and the last concept of functions that I want to talk about are closures. So for those who don't know what closures are, closures look at the scope uh, of a particular variable, and based off of that, functions can capture variables from their surrounding environment. And I'll show that right here. Fine. Yeah, and for this example, we are going to be implementing an adder function. So in Haskell, if you've implemented like an increment function and then added an additional parameter when you're calling it outside the function, yeah, it's similar to that. So you have an adder n function with lambda x and then x and n. Here we just have here in this lambda function we call a parameter x that would be fetched outside the scope of this adder function, while n is just our input parameter for the adder function. Uh, then we define an add5 function, which is adder 5. And you can also define an adder 10 function. Yeah, so we have two adder functions, add5 and add10. And to see this in action, we just do add 5 times add 5 function with an input parameter of 3. And if we run it, we get an output of 8. That is because here, for our adder function, when calling the add 5 function, the lambda function fetches 3 as its value for x. And if we were to do the same thing for our add 10 function, so we keep it at 3. Okay, yeah. Let me just do it. New line function. Yeah, here we see it outputs 13 after we call the add 10 function with 3 as an input parameter. And yeah, finally, how do we make custom data types in Racket? And how we do that is we use structs. So if you've used C in the past, yeah, structs work the same way. It's similar. Yeah, it all it does is just encapsulate variables and stores them into a single unit. Here we could use a struct keyword and make a person struct. So in this case, we have a person with the name and age attributes. And to create an instance of a struct, we would just do define p1 and then person. Let's name this person Alice, and she is 30 years old. Actually, instead of naming this P1, let's call it Alice. And you can summon a person's name and age. So person dot name Alice. You run that, we get Alice. Likewise, we can do person dot age Alice, and we can get 30. Uh, and yeah, so thank you very much for watching. Uh, here, this is just a basic walkthrough of the Racket programming language. If you're looking for more information on how to uh, use Racket, I found this excellent resource from the University of Waterloo, Canada. Uh, that teaches everything from figuring out the basics as well as pure and impure functional programming. Uh, so you can have a look at that at your discretion. Uh, but overall, thanks for watching. Peace.